All right, everybody, let's wrap up our discussion of factorial ANOVA by applying it in hypothesis testing. So here we go. Remember, we have our general question: does college major and gender interact to affect class attendance? So the research question specifically states, is there a significant difference between the combined average effects of college major and gender on class attendance? So we have our same 7 steps for the factorial ANOVA. It's the same 7 steps for the one-way ANOVA. We just have to deal with a few more F scores, right? Because we have an F score for each independent variable and each interaction. So let's jump into it. So we already have our variables here. We have 2 independent variables, college major being the first one because it's the first one listed in the question, with 3 groups there. Gender being the second one mentioned in the question, so it becomes our second independent variable with 2 groups there. And class attendance is our continuous dependent variable ranging from 0 to 6. How many times did they attend class over the span of 2 weeks? Remember, we have a 3x2 factorial design because we have 3 groups of the first IV and 2 groups in the second IV. Now, when you get to your hypotheses, remember that ANOVA hypotheses are always non-directional, so we've got that going for us. Now, when you're writing your hypotheses, there has to be a hypothesis for each variable and each interaction, because technically there are, think of it as like its own analysis all by itself, with each variable and then with each interaction. So this is what you have here. And I can let you look over the wording here because it's largely the same, except for the specific differences that you see there, with college major being the focus of the first hypothesis, gender the second, and then the combination of college major and gender for the second one. Now, the null hypothesis is going to be the same exact sentences. You just replace the A with the no. So there is no, because it's going to say there's no differences between the groups. There's no differences between the combinations. Now, what we're going to do for this course and for this section, your assignments regarding the factorial ANOVA, you're just going to focus on the interaction. You don't have to focus on writing hypotheses for each main effect. The interaction is really what we're interested in when doing a factorial, so that's the one I want us to focus on. So you really have to just focus on writing out the question, like it for an interaction, and then writing the hypotheses for an interaction. So the alternative specifies there's no significant difference between the combined average effects. You got to have that key phrase in there. Combined indicating interaction, average is the means, effects indicating the independent variable's effect on the dependent variable. List the variables in order, college major and gender, and then list dependent variable last. Essentially, the alternative is saying that there's some difference somewhere between the combinations. The null hypothesis says there's no difference between them, and so it's saying that essentially all the group means, all the combination means are going to be the same. So that's how you would write the hypotheses for the interaction. So let's put this all together. Remember, we have our 18 students here, 3 in each combination of gender and major. We have a research question, we have our independent variables, we have our dependent variable here, and we have our hypotheses abbreviated for the sake of space. And then we have our F score for the interaction. Now, when you do your hypothesis testing for the factorial ANOVA, the software is going to calculate all the F scores for you for each main effect and each interaction. You need to specifically focus most of the analysis on the interaction, but there will be a few questions towards the end of the assessment that's going to ask you about the main effects. So don't completely disregard them. You're not going to have to do a full hypothesis test for each main effect. That's only for the interaction, but you will have to answer a few questions about the main effects at the very end. But let's focus on the interaction here. So we have an interaction, an F score of 8.18, and we have to ask this question: how likely were we to find this difference between the combined average effects of college major and gender on class attendance? So what we need to do is find the probability of that F score, right? And if it's less than 0.05, then finding the difference was unlikely. So you have to find a critical score, an F crit, and you compare it to your F score, just like we did with the one-way ANOVA. Now, the way you locate it is the same way that you did on the one-way ANOVA. The DF between, which is the DF for each variable in the interaction, right? That's your numerator. DF within is the denominator as it was before. This is an example, again, of how you find it. Find the column, find the row section, find the specific row for your alpha level, and then the intersection is the crit score you need. So just for practice, let's go ahead and find the crit scores for all three of the F scores that we have. First for the interaction, and then do it for A and then for B. Now, the crit scores that you should have found are 3.89 for the interaction, 3.89 for the main effect of A, and then 4.75 for the main effect of B. So let's look at the interaction. We have a crit score of 3.89, has a probability of exactly 0.05. Does our interaction F score go past or before it? It goes past it, much past it. So we know that it has to have a probability much less than 0.05. Okay, so because it goes past, there's a probability less than 0.05, meaning that assuming that college major and gender don't interact to affect class attendance, this was pretty unlikely for us to find the differences that we found between our groups. Assuming that there is no difference between the combined average effects of our two variables, this was unlikely for us to find the differences that we found. So that's evidence against the null. So we reject it, accept our alternative. That becomes our conclusion. And so we restate the alternative hypothesis for the interaction. And then we need to put it back into its general wording, like from the general question for a general conclusion. And you can say something like college major and gender both affect class attendance. And that is the answer to our question there. Now with a factorial ANOVA, you can use a visual to kind of show what's happening with your variables. You wouldn't use a bar graph, you would use something called a line graph. Because you have two variables here, here's how it typically is represented. The y-axis is showing your dependent variable, showing your averages, right? So the average we know is from 0 to 4. Our averages did go higher than that, so I didn't bother showing us 5 and 6. So it just goes from 0 to 4. The x-axis is our first independent variable. So it's college major. So we have psych, soc, and bio. Our second variable are the lines. So male being one line, female being the other line. Now you can see how males and females compare to each other in each college major. Now one of the things that indicates that the variables are interacting with each other is if you look at the line graph and you see the two lines crossing, that indicates an interaction. If they did not cross, then there would be no interaction between them and we wouldn't find what we found in this analysis. So you can see that males were going to class more than females in psych and soc, but not biology. Females were going more than males in biology. So it seems that the major and gender were having some kind of combined effect on class attendance because we see that in some categories, some majors, males are higher, but in one of them, males are lower. So they have to cross, they have to interact in order to produce that kind of result, okay? So that's a visual that you'll have to do in your assessment, and you can use it as an indication of do you have an interaction that you're working with? Now, lastly, what are some questions we might ask? Well, simply, we would ask, is there any significant main effects? Okay, so we can see that the critical score for the main effect of A is the same crit as the interaction, 3.89. And the calculated score, 13.11, goes much past the crit score. And we see that the crit score for gender is 4.75, and the calculated score is before it. It doesn't go past it. So what can we conclude about that? We can conclude that there's a main effect for college major, but not for gender. It seems that college major is having an effect on how much you go to class, not so much gender when you look at them by themselves. They interact to affect class attendance, but gender is not having much of an effect on its own, whereas college major does on its own. So you'll have to answer questions similar to this when you do your factorial ANOVA assessment. And so this is how you do the factorial ANOVA in the context of hypothesis testing.